thank you guys all for being here too. It should be a fun night. Corbett, it's your show, so I'll let you take over.
Okay. Grace is technically the boss, so if she wants to jump in on anything, then she's, but just raise your hand. You don't have one of these things, and Matt and son are.
It's okay, I'll get in and I'll whisper.
Great, okay, do that. I'm gonna invite you guys one more time, and then I'll stop doing it. You're welcome to find a seat. You can sit on our lovely couch. That thing gets beat up by our kids all the time. You can't possibly hurt it. Also, piano bench, also all of the chairs.
Yeah.
Okay. So I have up here some test tools. I have here some young ladies. They will be showing you around. What we're gonna do is just talk about some stuff. I'm gonna tell you, this is kind of exciting for me because you guys are a group of nerds that are a caliber that I have not had. We had Carl Seville's and Abe Kruger's company come out, and they brought like 10 of their employees, and we showed them around while we were building. And it was funny to watch their face when they were like, wait a minute, you guys are building this? And I was like, yeah. And they said, you framed this? And I said, yeah. And they were like, okay, cool, man. Like, why would you do that? So I wanted the cred of like having done all this stuff. So like I installed the duct system in our crawl space. It took a long time, but I know how to do that now. I installed the ERVs and da-da-da-da. Like, so being able to know how all this stuff actually gets done, I think is a missing link that a lot of us don't, so being able to talk the talk with the contractor, the architect, and the engineer and all things. That was part of the goal. That tiny house called the Tiny Lab, this is like what it looked like on a typical day. Nanette was 6 weeks old when we moved into that. In 2016, we hit the road. We went 13,000 miles across the country. We visited 34 cities. She was a baby. We had 2 cats. We lived in it 200 square feet. You'll see that out there. It's special.
You can all applaud for me now.
Wait, laundromats? Yeah, I mean, like it's an off-grid kind of a thing. So, excuse me, baby, excuse me. So I'll talk about all this different stuff, but basically just welcome. I will say also, we're gonna give away a couple things here. Where are my things? Okay, number 1, Air Things would like to give away a Corentium radon monitor. Radon, super important. We talked about it last time. Shane, where are you? Raise your hand. Wherever you are, yeah, great. So radon, we talked about last time, important. Thank you very much. That is a digital radon monitor. You can take that around with you and put it in your clients' houses or whatever, if you want to take it home with you. I also have a book, Home Performance Diagnostics, which is the guide to testing, basically. I didn't invent any testing. I'm just kind of a communicator. We try to tell the story of how you use this stuff intelligently. And also I've got hats, 3 hats here, Home Diagnosis, which is our TV series. You have one already. That you don't wear. They're for people who ask questions that I have not heard before. So if anybody has an interesting question, feel free to ask it and not you.
And then also the one other thing that's probably, it will not be a giveaway, that is for sure, but it is something that is going to be leaving our lives. And you will be the very first to know that at the end of the year, we are going to be selling our tiny house that comes with our truck. I know it's a big deal, but also it served a season and now it should serve somebody else. And so we will be releasing details on that. But if you are interested or thinking about it, you can, you know who to talk to.
Okay, so let's begin. So I gave a talk on ventilation in this group at South Face last fall. It was October, I think. And I'm just gonna blast through this because you guys already heard me say this. So there are in-home performance, part of the thing that we try to do is explain this so that we can all kind of hold it in our minds the right way. 4 elements to home performance, 3 recommendations to make, 2 systems, 1 goal. The 4 elements are heat bleed, airflow and pressure, moisture, and contaminants. Contaminants can be in the air for indoor air quality. They could be in the water. They could be on surfaces. It turns out that dermal exposure from you touching stuff is actually exponentially higher than you breathing stuff in, according to the chemists that we work with. We work with these chemists at the Sloan Foundation's Chemistry of Indoor Environments program. Anyway, I'm gonna talk real fast. You can see all of what I'm talking about on the YouTube channel, so please do feel free to do that. 3 recommendations are always air sealing first, insulation second, mechanical systems third. Mechanical systems, HVAC contractors in the room, raise your hand. Raise your hand, buddy. Get that hand up there. Yeah, that's right, okay. HVAC it can be perfect, and it won't work if the enclosure doesn't work with it, right? The enclosure always wins because it's passive. It's just like Grand Canyon and a river. River's gonna win. So the 2 systems that we're looking at, and what you're seeing here This house and the tiny house are this way of thinking put into physical objects. The two systems that we're looking at are, I went through the 4 elements, 3 recommendations. 2 systems are enclosure and engines. So the enclosure is the skin, air sealing and insulation. Engines are mechanical systems. Anything moves heat and air around within the house or between the house and outside. All that stuff needs to be tuned, and they need to be tuned to each other. Again, enclosure wins if there's a disagreement. One goal is what? Not sustainability, not energy efficiency. Does anybody know what I'm gonna say?
C.
Not comfort. Who's married in here? If I ask you and your husband, when I do your HVAC design soon, what temperature do you like to see on the thermostat? Are you gonna tell me the same exact number? Nope. No one does that. You're not giving people comfort. Stop saying that. You're giving them control. If they want it to be her temperature, you can do that. If she leaves town and I can have it my temperature, which I did last weekend, I raised it 1 degree because I was like, oh my God, I can have it be what I want. And I immediately, like a good boy, turned it back down as soon as she came back. But that's what you're really delivering is control. Health is definitely a side effect for sure. Energy efficiency, and by the way, health is a big thing for people. They want that now. Energy efficiency side effect, sustainability side effect. This is how you know you have control. If you are not doing this, you have no idea what's going on. I had a client last week in Santa Cruz, California. I do a lot of Zoom consults for people. I'm kind of like a second opinion doctor when they're working with somebody who might be a high performance builder or might just be a regular builder. And they're like, hey, here's what we're doing. What do you think about this? And we spent an hour on Zoom. And you could see my hourly rate on my website. I'm telling you that there's a huge need for that. We need more people doing that. I'm booked out 2 weeks in advance. I'm like one person. So please, know that this is a thing that people need help with. They are willing to be the CEO. You're the CEO of your project, right? You're going to be driving the builder. And my clients around the country who watch the YouTube channel, and by the way, you guys should all have videos that you're making and explaining the stuff to people because we all need to be talking about this more. They are going to become radicalized. They can be radicalized in 1 day. They could binge watch some YouTube videos and suddenly know more than any contractor in their area. And they are going out there and they are scaring the crap out of realtors and builders and contractors every day. It's very fun. I love it.
Knowledge is power. And one of the things that we learned on the tiny house tour is entitlement is the characteristic of an American. And so they grab this knowledge and they take it forward. And so be aware.
Okay, so we're gonna do some of this today. Again, we're gonna be real fast about this, and then I'm gonna let you set yourself free. You can wander around. You're gonna have this room. I'm gonna be stationed in here. You can come ask me whatever you want. I will tell you literally anything you wanna know. Grace is gonna be in the master suite. You can look at ventilation stuff in there and do some testing with the flow finder, with the, probably just the flow finder. But you can kind of see how our ERV system is set up and see that it's not scary to do it the way that we recommend because we live with this. Emily's going to be in the studio crawl space. You're welcome to go and take a look at that and see what a real crawl space looks like and feels like. I had to drag my code team down there to before they gave me the CO, they were just we're going to just give you the CO. It's fine. And I said, no, you have to see this crawl space. I want you to know what it can be like. And then Nanette is going to be in the tiny house and you can see pressure testing of what the makeup air system does out there, how a passive makeup air system works outside, how an active makeup air system works in here. We're going to test both of those. Okay, so here's the blower door test. Tiny house. I'm just going to explain this real quick. That number right there, so 50, 51, 48, this is your pressure. We hit 50 pascals. So it's called CFM at 50 pascals, or in code terms, ACH 50. Have you guys heard this? Okay, so you set the blower door up in the door, just like we have it over there. Trey is going to be my blower door expert. He's my local mastermind. If you don't know Trey, standing right there, raise your hand. Again, helped build the house. He helped me install insulation and ductwork. The house has a WRB membrane over regular plywood. Rain screen, as you can see, these are core event battens. We've got the siding and all the stuff that's out there. That thing is built to be a vehicle because it traveled 13,000 miles. I mean, you know what happens when you pull a tiny house on the road at 55 miles an hour on the highway? It's a hurricane and an earthquake at the same time on a regular basis. We did that 13,000 miles worth. And that thing is solid still. We could do the blower door test on it today and it would still hold up, partly because we did not use spray foam. This is a big thing. Partly we built this thing because we wanted to show people building science in general. If you can understand building science in that thing, you can understand it in your house and go, I never thought about da-da-da. But also, tiny house people are crazy. And we wanted to show them hey, don't be installing a bath fan because here's 50 pascals. There's our CFM 50. This means that if I installed a 50 CFM bath fan in that house, I would be doing a blower door test every time I ran it. That would be a nightmare. You cannot have a single bath fan in that house. So we need to have what instead? Balanced ventilation, ERV, boom. That is why generally I'm recommending ERVs, because you cannot have bath fans. Lots of builders out there building so tight that you can't have bath fans, but they don't know it. So the Santa Cruz guy I was telling you about last week spent the whole hour with me on this Zoom call being like, I can't believe that I did this so badly. I'm so embarrassed. He built a very nice house. It looks very nice. It's got all the things, right? You're like nodding your head. And this is exactly the problem with your house, exactly, right? So Enclosure, mwah, perfect. Oh man, so good. But HVAC didn't get the memo. Or the builder did not. Do you guys, how many people are builders in here? Okay, great. Last house you built, do you know what the ACH 50 was? 0.6. Hell yeah, good. Who else raised their hand? Do you know what the ACH 50 was?
1.25.
1.25, great, okay. You guys are freaks in a good way. Most builders get the piece of paper and then they don't even look at it and they hand it to the code guy. Like they do not know what they're blowing. So please feel proud about the fact that you actually look at that piece of paper and then you might actually keep track of it in a database, maybe on an Excel spreadsheet, something like that. So that when somebody asks you, hey, how tight are you building? You can be like 1.25 or 0.6, and that's awesome. So that's number one. You can't use bath fan. This is ACH 50. This thing is 1.4. That's not as tight as what Steven built last time. But that right there is passive house airtight. Passive house is 5% leakage per square foot. So ACH 50 punishes small houses. That thing is 200 square feet. It gets punished by ACH 50. So it doesn't look that tight here, but if you actually use the square footage of the floor and the ceiling and the walls, suddenly it's passive house. First time out, didn't know how to build a house. I had to learn how to use a nail gun to build this thing.
He really
Right.
wanted to use just a hammer and nails. And I was like, no.
Yeah, all right. She wanted it to go a little faster. So 5 months or 7 days a week, basically, that was this. This is this house. 50 pascals, 309 CFM50. Trey, this was 5 years ago. Okay, we blew this. Would you please go ahead? Who wants to guess what ring we take off on the blower door? Those of you who know blower door. It's take off the two little guys.
Make sure the front door is closed.
Yep. Yeah, can we make sure that the front door is closed? Yep, we're good. Okay. All right. Fire up to 50 if you would, please.
Do we need our suite open?
Yeah, sure.
Door.
Yeah, would you? It probably won't matter, but 50, yep. There's no gas in this house. This is an all-electric house. Makes me feel better. If we did have gas, we would want to make sure that we did not have anything active, because if it fired up while this thing was running, we would be maybe setting the house on fire. Hence, you don't want to do a blower door test every time you run the bath fan. Okay, so you can see it's kind of trying to dial itself in. We're at 290 right now. This number right here, 310, was without Intello interior membrane. I got 20 CFM out of spending all this time house wrapping the inside of the framing also. Was it worth it? Like, if you look at the numbers, not really worth it for the time and the expense. But number one, I and Matt Reisinger and other people you watch on YouTube, and tell your clients this, please, do not pay for the things that we build with, right? So our risk assessment is not the same. So please don't do whatever Matt Reisinger does on his channel, because he doesn't pay for any of that stuff. Tell your clients that, remind them, because they're like, well, I saw Matt do it, so might as well. So that hasn't changed in 5 years. Blower door tests don't slip. Cracked spray foam, in the case of shifting, that might be a little bit of a different thing. That's why I use flexible membranes and stuff like that. By the way, go ahead and hit stop on that for me, Trey. Oh, you know what? Actually, don't. I'm sorry. Take us back up. Take us back up. Yeah, I want to show you something else. See that one over there? That manometer that's next to the bookshelf? Will somebody read the pressure that's on there? 1.3, 1.4, okay? That is the crawl space of this house. It's a conditioned crawl space. It's supposed to be inside. Every room in the house should be either completely inside or completely outside. No gray area. That's just asking for trouble. So that crawl space, now we're back down to right around 1, right? So whatever, it's 1 when you round. That is what you want to see. If it was a vented crawl space, what would I want it to say? Does anybody know? Trey? Yeah, total step means 50. It should say 50 if it was a vented crawl space. It should say 0 or 1 if it was a, right? We generally like to say, hey, shoot for like less than 5. If it's supposed to be an inside space, shoot for more than 45, it's supposed to be outside space. If we had an attic, we'd want the attic to be 45 to 50, right? Et cetera, et cetera. Every room in the house should be the same exact thing as that. Yes, sir.
What was your CFM 50 that you read just a moment?
What do you got right there, Trey?
280.
280.
280. Does that Recitech have the ability to be set instead of 50 pascals when you set it at 3?
At 3?
Yep. I'd be curious what your CFM 3 is.
Trey, set us up for CFM 3. Take us down to B1. While he's doing that, I'm interested. Sure.
So I would also like to confirm whether you've heard the same information, but I've heard that if you said you do not have any combustion appliances.
Right.
If the home does, tests have been done not by me or my company at all, but we've researched this a little bit just on the internet. But supposedly 3 pascals is sort of that threshold where you can backtrack the combustion appliance.
Sure. 2 actually for a water heater, for like an atmospheric draft water heater.
2, but so what I'm saying is, what I'd like to know is if you can set it at 3. I think I have it calculated from the CFM50. I'm pretty sure.
You could do it if I gave you another number. If we did the 25 also, then you could extrapolate the 3. But yeah.
No. Right. If you made a CFM50, and then I think I can calculate for any.
Sure. Go ahead.
So what I
just 3 pascals. Yeah. You need to take us down to 1 hole to outside.
If we know what the house will do at 3, we can say then we should have compensation for any exhaust that exceeds that.
Yeah. I hear what you're saying, but trust me. What you can use is an easy way to do it. There's a depressurization calculator at RedCalc. So if you search RedCalc, it's owned by the DOE, PNNL owns that now. You can go and there's a depressurization calculator. You put the CFM50 in there and you put what the CFM rating is on the fan, and it'll tell you, extrapolate what the depressurization would be. Do we get a number over there, buddy? Probably not, right? Yeah, that's cool. Don't worry about it. Go ahead and hit stop. Plug me back up, please, Trey. Okay, so any questions about blower door? Okay, super important. If you're gonna do one test, that's the test. That's the one that really matters. Lots and lots of people building much tighter than they think they're going to. And that's why HVAC guys, we've got to get them on board. And that's why trade school is so important because, yes, sir, please.
In the last 3 weeks, I had approximately 21 DET verification calls. And every builder in Atlanta, from Henry County, just been pretty much fabricating the paperwork. And it's at a point right now to where I'm starting to see now that if people don't start to change, that the communities now are being affected because most houses have failed in almost a year time, but like a day one, they done failed mechanically. And cosmetically, a lot of things going on. So I'm just saying we gotta do more to push this here testing, and because it is getting that bad.
Yeah, because they think they're paying somebody to not test because they think they're gonna fail and they want to pass. But really, they're like passing with flying colors and they're not knowing how dangerous it is. Go ahead and plug me back up all the way. I wanna look at one more thing. So actually, wait, I'll try and follow the format here. Okay, so next, tiny house. Let's talk about the tiny house in detail here. This is what it looks like on the inside. It's all pure bond plywood. It's because drywall would crack at the seams because it's earthquake and a hurricane at the same time. So we built all of this stuff like that you see. So I'm happy to answer any questions that you've got because we subcontracted in here. I built that thing with my mom and dad. Grace was pregnant. Built this thing with my mom and dad. Grace is pregnant. So she didn't really, she helped me install like the windows. That was a cool day. But in general, we subcontracted drywall and roof and stuff like that. The roof, by the way, on this thing, I love so much. 24 gauge, standing seam, Kynar coated, $30,000. Love it. Okay, and I'm happy to give a referral on my roofer if you want. So Tiny has a mini split on the wall here. We also have this thing that you can see that looks like it's a design detail. It comes here, and then we kind of shoot the recessed, the light, which are a little like, they're kind of like puck lights, but they're a little bit recessed. I didn't know what I was doing. I'm not a good builder, as I said. Like I had to learn how to use the nail gun. So we just kind of do stuff, and then, so you don't look at my baseboards, for example, if you're a builder. But we take exhaust out of this end, And you'll see this in the studio as well. So if this end is our exhaust end, we've got the kitchen down here. Plumbing is very short also because we've got the shower on the other side of that wall, sink right here. So plumbing, very, very small. Exhaust taken out of the bathroom. Here is your return pathway for the air to get in there. 25, 30 CFM tops. That's 1 ACH in this tiny house. That tiny house is 1,800 cubic feet of air through 30 CFM, which is the lowest that you can turn any ERV to, is 1 complete air change per hour geometrically. It doesn't really happen like that in real life, but it works. It's just fine. You'll see that we've got a dehumidifier that's standing here along the kitchen counter now. And that's very important because mini splits don't do what? Dehumidification. They don't do it very well. Especially with the new refrigerant, by the way, be careful. Make sure that your guys are checking the actual performance data on that stuff because they're doing not that great. So we sleep down here, dining loft is up here. I have a little, right here, there's a little hatchway and I've got a damper that I can have the fresh air come down and dump into the under loft, which I do in cold, dry weather. And if it's hot, moist weather, all the soft stuff in the house is down here, clothes, bedding, all that stuff. I do not want that humidity come down here and charging this like a battery. So I block that off and all of the air comes up here, goes across and gets mixed with the conditioning air. And then I've got that fan on high and it shoots it down and around. And then we've got this little circulating fan that kind of pushes air from here to here. Kitchen exhaust hood, you'll see that. Nanette knows how to run that in the other room. She's gonna turn on the kitchen hood. You're gonna see that the house goes almost to negative 150 pascals. You will feel it in your ears when she turns on that kitchen exhaust hood. That is a $300, 300 CFM kitchen exhaust. Goes right outside. It's beautiful, but we need makeup air and you'll see the little 8-inch makeup air damper down there open up and it relieves the pressure down to about 15 pascals. That's like
a refrigerator would be there, FYI.
Yeah, normally there's a fridge there. Let's see. There's also a composting toilet in here. The composting toilet has its own little exhaust that pulls down, so air goes down, which is inspired how we lay out the ERVs next to the toilets in this house, which I'll show you in a minute. So you never smell anything even when you're in the house. So air is taken out of the house here, air is brought into the house here, so there's a tidal movement of air up through the house that way. Okay, energy-wise, people ask this kind of thing like, is passive house important? It's so not important in this case that it's like kind of a joke. So I like to make sure that people know. It's got 2x4 walls. I have R15 rock wool in there. This is what it costs per month on the heating and cooling, right? Or excuse me, per year, right? And then your service charge, $108. So $25 I'm spending on heat, $40 I'm spending on cooling for that little mini split in there. By the way, quickly, this is something I'm particularly proud of with that thing. We did not do this on purpose, but it ended up that way. That thing runs on 15 amps. So you will see that it is plugged into one outlet. There's no 30 amp, 50 amp, whatever. That whole thing with the mini split and the computer that I make the TV show in, all our videos and do HVAC design work in there, that's running all on 15 amps. So this upgraded to open cell spray foam, no change because there is no difference in R value between insulation, right? The spray foam is not special. It might do air tightness, but if you've already got air tightness with something else like a WRB sheathing or a membrane or something like that, then you don't need whatever this is gonna do. Also, this would crack, no change. If I upgraded to R25 closed cell spray foam, which is like, let's just see what happens. I save a couple bucks. Is it worth it? No, it's not because here's my load calcs. So here's my distribution. We've got more walls in there than anything else. We've got floor, we've got roof, we've got glass in there. We've got a door that takes up a huge amount of space, like proportionally. We've got some air leakage, very, very little bit. You can see it laid out here also. What we end up with is total heating required 4,000, total cooling required 2,200. Does anybody know what the smallest ductless mini split you can buy in the world is? 6,000. So if I made this place more insulated, what am I doing? I'm pulling apart my enclosure. I'm making it more detuned. I'm having my enclosure and my engines not talk to each other like crazy. I need them to be able to agree. In fact, it's so interesting in there that we used to not park that in the shade because I need the sun to shine as hard as it can on that house so that the air conditioning runs, so that the dehumidification runs, what little bit we get out of it, which is like, some. That kind of a thing can happen in this case. So this was a real, this is called AED. I'm gonna get into that in a minute. So again, improving the glass. Why didn't we go triple pane? Why didn't we go with a better wall package? I'm so low already, it doesn't matter. None of this matters. In fact, in a normal house, like anybody who's a client of mine in here, you're already, before you even start value engineering, being like, well, what if we had continuous installation outside the walls? What if we blah, blah, blah? And this house, you'll see it does have continuous installation on the walls, but not on the roof. If we did do that, I'm gonna have even more of an argument with my HVAC installer because he's gonna hate my guts. Because like, I'm already upset about this 2 tons that you wanna put into this big house. Like, that's crazy. Do you know what you're doing? Like, no, you don't. I've been doing this for 55 years. You've been doing this for 6 months. Trust me. So you just try not to engineer too far. Adequate exposure diversity. Okay, so this is what happens. Sun comes up at 8 a.m., sun goes down at 7 or 8 p.m. This is out of Elite Soft. Right Soft is what I use now. You'll see different kind of formats for this stuff. One thing that Elite does that Right Soft does not do is this. This is room by room what happens throughout the course of the day. So you can see every single room on this. Some of them peak at 5 o'clock, which is very typical. Some of them peak up here in the morning at 10 a.m. So this kind of knowing what the characteristics are helps you inform whether you're going to do zoning or not. If it's like this, we might need zoning because whatever's pointing this way at that time of day at 1 p.m. is going to call for way more than the thing that's facing the opposite direction. But the numbers here are very important. You always want to look at like shapes and colors and stuff, and that's why the infrared's so dangerous. You guys are going to use this in a little bit. Colors are nice, shapes are nice, but really, like, look at the numbers too, because the spread here is from 2,500 to 2,100. That's 400 BTUs per hour. That's like not even a 20th of a ton. No one cares. We do not need any zoning in this situation, okay? So that kind of happens in normal house too. We could see which way we want to park the house, right? Because I can park that house whichever way I want to. We can know what the sun is going to do through the windows at every point on the compass. So that's kind of an interesting side effect. The mechanical shed is where you're going to see the mechanicals. Feel free to just open it up. It's unlocked. In there, you will see there's an ERV, not an HRV. And I know what the difference is because I have lived with both. We started out in an HRV, partly because we had Lou Harriman, who is a friend of mine who does dehumidification. He's written several books on dehumidification for ASHRAE. And Brett Singer from Lawrence Berkeley National Laboratories, both very nicely contributed to this project. They both insisted that we would have high humidity inside, low humidity outside, because it's a tiny space and we want to make sure you get that humidity out. HRV, definitely. Has anyone heard that before? I swear I've got clients in all climates who say things like that, or they'll still think like, oh, ERV is for warm, humid climates, HRV is for cold, dry climates. Totally not true. We toured with this thing having an HRV core in it for like 3 months, and it was just killing me. It was so humid, so problematic all the time. And then I just found out like, oh, you can actually just switch the cores. So we did that. And I found out like, oh my God, that was the whole problem. ERV all the way. And now I know living with this stuff is really important. Who has an ERV in their house? Great. Okay, that is the way you know, is that like you know, you go outside and you're like, oh my God, I can feel what this thing is doing to my house. Most HVAC guys who are speccing this stuff do not know that. So just beware, please, that kind of stuff can happen. The propane tanks, we had this be an off-grid house. That's why it's 15 amps, no heating by electricity. The heat pump pulls about 300 watts in cooling mode and 800 watts in heating mode. Solar and batteries, again, the thing runs on 15 amps. I don't have my solar panels out here because I think it's kind of a pain in the butt. I don't like how they have to cycle up and down, and then my batteries need to be replaced in 5-10 years. And I haven't even reused them necessarily. I just have to keep them maintained and charged. Yeah, right. So the water heater, they're mostly for backup. The water heater in there is, again, running on propane. It's very, very small. The low activation is a problem in there. You guys are probably not building tiny houses. I do not recommend it in general. In fact, this builder who is in Santa Cruz that I was telling you is super embarrassed. His house, 1,200 square feet. Same problem, same brand of problems as a 200 square foot house. So this was the build of this house. And again, my parents, my mom and dad here, my mom and I both fell into crawl spaces during the course of the build. Nobody else got hurt. I built the things that we did to prep for this because, again, not a good builder. I built the house in SketchUp in 3D first so that I would know how I wanted everything to work. And then I ran it by a structural engineer, and he was like, okay, cool. And he redlined the whole thing and was like, here's what you want to do with this. So like we had definitely help. I was not DIYing it to the extent that some people do with tiny houses, that's a whole different conversation. But I love people doing self-builds. I think that's a great idea because like we need more people who know how to do things. I think we can all agree on that. Also, how many pieces of sheathing, ForceField that we needed on the outside, all that stuff. Here's what the Manual J looked like on this house. The adequate exposure diversity, which again, sun comes up at 8 a.m., sun goes out at 8 p.m. This shows that we're fine. If you pass over the red line, we need to think about like maybe zoning, because that's our main problem is 5 o'clock. This is the studio. What's going on there? There's no windows in that room. So it doesn't have any adequate exposure diversity. It's fine. So that can happen.
Do you know what studio we're referring to?
You're going to see it. It's the recording studio. I do
The
my
other
office work
portion
in
of the
there.
house.
Yeah, for those of you who I Zoom with, that's where we do that. Here's heating. Here's cooling. Walls R15. Even though we've got some 2x6, you can see these walls right here are clearly 2x6 framing. I only filled them with 2x4 because insulating different walls to different R values doesn't make any sense. Heat follows path of least resistance. Just do everything same way everywhere. We have R8 continuous on the outside. Got Georgia Pacific ForceField. By the way, this is really important. Have you guys ever worked with Georgia Pacific ForceField? Ever heard anybody talk about it? You worked with it?
We did.
Yeah. When it got released, yeah. What'd you think about the tape? Okay, cool. This house got that number with Georgia Pacific ForceField, which is a commodity version of Zip, invented by the same guy. I've got videos with this guy, by the way, on the channel. His name is Landis Bennett. He's awesome. Backwoods genius kind of guy. That tape seems silly. Like anybody who's a builder would be like, I don't like this. It feels like shipping tape, right? It's shipping tape. It's okay. And it's lasted 5 years. It's not having the sun beat down on it. It's gonna last for 100 years back there. Like you don't have, thick doesn't mean better, right? So just like know that kind of thing can happen. And that's why doing things yourself, I think is very useful because like a lot of guys who are, I'm not saying that experience doesn't make things better, but when you are approaching things the way Steven approached it, which is a professional builder, he doesn't want his client to call him and be like, I feel like you're cheating me on this tape. Like, that's not my problem. You know, I want to do the thing that's like the experimental because we're trying to tell a story. What were you going to say, Chris?
Flapping in the wind.
Oh, yeah, totally. I mean, it's laminated different for sure.
So you're saying that when you said the comment about not insulating because heat finds a path least resistance. So if we're doing a renovation on a 100-year-old home and part of the home doesn't have insulation, the whole home doesn't have insulation, you're saying it's not even worth putting it in insulation in the area that you're renovating?
I'm saying, in general, if I was going to do an HVAC design for that, I would want to do the whole house. And then you would see that us insulating this little addition thing doesn't actually make a dent. Like you could insulate it or not insulate it, and actually the sizing won't change that much for the whole house. It might make that particular room a little more comfortable in certain situations. Yeah. And I'm not saying that that's not true, but like globally, it's a system, right? That's the most important.
And for perspective, literally we're doing the exact same thing with my mother's 115-year-old house, and we insulated. You know,
yeah. Because you're working for clients. You guys are working for people, and you have to not just do the thing, but you have to sell them on the thing, and you have to like show them that they have to understand that you're doing a good job, right? I'm not under those constraints here. So I was able to just experiment and be like, there's no one who's going to give anybody a hard time because it's just me who's going to be pissed off at the end of the day. So I got to do some stuff to see, basically. Some of the framing in here is 2x4, like I said. So we had to do R15. Okay, so R8 outside on the foundation walls, they're bare inside, you'll see in the crawl space, but R12 outside there, that made the sheathing line up. I used FRP. This is a major thing for people. Does anybody else have any good ideas about how to clad exterior insulation on a foundation? FRP is fiberglass reinforced plastic. It's what you see on the inside of gas station bathrooms. It's pebbly. Look at it when you're outside the house. I think it works beautifully. No building manufacturer would warranty anything, cement board included, that goes down to the dirt and is in the dirt. They were like, no. So I was just like, well, I'm gonna find something that does this. Does anybody have any better ideas? Yes.
Yeah, it'll be out on my channel in about a month. But like the challenge, like especially with a lot of the installations, when you go below grade, and especially if you're using stucco, you got to come on that flashing transition. And I've got something worked out with Durkin. It's some flashing, some Corbett. There's like 50 different products to do it.
Right.
But for that transition, you're either going to do it right or it's going to be ugly, or you're going to have turnoffs. So
yeah,
I think we've got to figure it out.
Cool. Yeah, please. I'd like to see that. Okay, so you can see heating, 26,000, cooling, 18,000. This is just this portion of the house, by the way, not the studio. Studio has its own, it's totally air sealed away from the house. It has its own heating cooling system, its own ERV, its own ventilation and dehumidification, and its own crawl space, which is the one that you're gonna see today. This number is fake. always. They're rewriting Manual J partly to try and solve for that right now. My parents' house, that number told me 65,000. I unplugged the electric heat strip. Their house is right there behind ours. Unplugged the electric heat strip, ran it at 75 degrees right here, 4 feet above the floor in their house during 3 design days in a row on the winter condition. And it held 75 degrees, no problem, with 30,000 BTU heat pump. Brent Ridley, actually, the guy who installed that one and this one in this house, he might have been in this group once upon a time, but he said, I don't think you need those backup heat strips. And I was like, Brent, I did the math. And I had to go back and be like, man, I'm sorry, you were right. That math is wrong. So there's assumptions built into this stuff. So anyway, what we've got down there really is a 2-ton P-Series Mitsubishi. This was the house under construction, no insulation. This is just thermal mass, taking us from about 73 degrees up to 80 degrees. This is May, probably. Is there a date on this? Yeah, there's dates. Can you guys read these dates? So 73 up to 80 every day, and you can see when weird stuff happens. But that's basically day, night, day, night, day, night. You can see that the relative humidity, however, which is the orange line, is flat. Because what did we have installed in the house when we were building it? Dehumidifier. Do that. Always do that, because you're drying out all this stuff, and it's just, I found it so much, I felt so much better about like waiting, or like, oh, whatever, nothing's happening today. Or guys are coming and going all day long, opening the door, and it's like June or August or whatever, and I'm just flooding with humidity. I've got this big ass dehumidifier in the crawl space that's just constantly keeping everything normal. I highly recommend it. We did this. This is Landis Bennett. He's the guy who invented this and Zip. He has a pressure washer. I have the blower door pulling 1 inch of water column, 250 pascals. We could do that right now. You guys could feel it in your ears if you wanted to. But that, at that point, we're pulling water up into the assemblies. And he basically just sprayed everything down, and we found all the leaks with the infrared camera, and then we marked them and we sealed them. So I know where all the leaks were, and then we sealed all of them before we went forward. That's the kind of thing I think for like selling. See how much better we are than normal people? Like, this is nothing. This is like so cheap.
It's just a power washer that we're just having a good time with. It was a little nerve-wracking.
Yeah, it totally was. Okay, so here's Grace in front of the house. Here's as you can see, the battens that we've got attaching the continuous insulation to the ForceField. We had thermal buck we used around the windows. That was like an interesting process. You can watch the videos about that. But it was like more complicated than I thought that it should have been. With all the roof and everything like that. The ridge beam is 56 feet long, and we did that without a crane. We didn't use any cranes on this house. I was very proud. By the way, also core event. This is the radon system in the house. This is what the fan tech is pulling on, is this slotted drain tile inside and outside. We poured up, so we can form up. Most of the time when they're found, you guys, is anybody forming up on foundations in this room? On your footer? Mostly they like to dig down into the clay and then just pour concrete in the hole. I didn't think that was very cool. For drainage reasons, for the drain tile can't be down at the footer, so the footer is always wet at that point. So anyway, I've got this thing so that now the footing is itself drained, and it raises the temperature slightly. This is something that we found out from Wisconsin from a buddy of mine named Joe Nagin. So anyway, the problem though here is that this connection point between the inner and the outer drain tile, I'm pulling on both of them. The gravel burrito outside the house was pulling, my radon was pulling on this, which was pulling on this, which was pulling on this, which was pulling on the gravel burrito, which was pulling all the way up behind the dimple board on the rock wool to my little flashing piece, and I was having to run my fan super high. So we came along with some caulk, sealed the top of that flashing. Now I can run the fan at like so low, you can go outside and touch it, and you can feel how soft that thing is running. Okay, here's the crawl space. You're not gonna see this crawl space. This is the main one that's under where we're standing right now. We have a dehumidifier. There's a 120 pipe per day. Santa Fe. This is a Mitsubishi 2-ton. All this ductwork I installed myself. I had John Semmelhack up in Virginia do my duct design. That was before I knew how to do duct designs, and I was like, I want this done right. And then I installed it. Line set, ERV is totally separately ducted in this house. Has anybody done that before? Okay, what's that? Why? Because I wanted to be able to stand up in front of people and say, I have one that was totally separately ducted, and I wouldn't do it again. So do it the way that's better, which is just dump the fresh air into the return, 10 feet up if you can, but before the secondary, before the big filter that you've got on your system, 4-inch pleated media, which by the way, we're gonna do that right now in just a second here, so that you can refilter it basically. Makeup air system is down there, all that stuff. Okay, here's toilet exhaust. All of them are like that. The exhaust is right behind it. So air comes in under the door, makes a beeline for that exhaust, doesn't let the odors in the toilet go up and soak your skin and your clothes and all that stuff and go up to the ceiling, which is the dumbest place really to exhaust from, if you think about it. Shower, that's the one. You guys can test that. What this runs is 20 CFM, or 25 maybe today if I'm on boost mode right now for the party only. 25 there, 15 there, generally. You can use this flow finder right here to actually test that and see that there are no boost buttons in any of my bathrooms. We do not boost in bathrooms in this house. Again, I wanted to experiment and see what's possible. It works perfectly fine. The mirror in that bathroom has never once fogged up in 5 years. So all you need is 25 CFM. Really, it runs 20 most of the time in reality. They go to the ERV. The ERV is like one fan that's pulling on all the bathrooms in the house and then basically takes it outside. You can see all those terminations outside here. Runs 24/7, yeah, you never turn it off. Exactly.
We also had one in our litter box when we used to have.
Yeah, you used to have to walk. So yeah, our cats are dead, but sorry.
They lived a long.
They were nice. So anyway, the litter box was right there in the hallway. Where you had to walk past it to come into the house. No one ever smelled the litter box because we pulled how many CFM out of my litter box? 5. Pulled 5 CFM out of the litter box all the time. Worked like a charm. No, because you were taking advantage of geometry, which we're gonna talk about in a second. Here, we're taking advantage of geometry. ERV supply, fresh heating cooling supply, close together. Very important because then they marry together and they both go in together, not separate. Far from the return path if possible. Here is our central return. This house has 1 return in it. How many HVAC guys in the room feel like you have to have a room by room return, right? I know, right? And that's why I want to show you this right now. Okay, so check this out. Over here, this is our 1 return. We got, again, we have 16-foot ceilings right there. We got 11-foot ceilings in that second floor, and I have a crawl space underneath me. And I'm going to show you in a few minutes what the temperature split across this house is. But first, this is a filter. What I want to show you here is, can everybody hear this? Let me show you this. This is a 3-inch pleated media filter. Can everybody agree that the pleats are roughly the same like distribution on these? Okay, watch this. Can you hear the difference already? Yeah? Okay, look at that. Negative 0.355 inches of water column. That's a lot. If you put this 3-inch in there, 0.17, like half. However, you also want to pay attention to bypass. So see how it's going through the filter? It's also going through this freaking foam on the side. So I have to actually tape up. See how it's disappearing into the foam? So I got to put tape around that whole thing, which is going to raise that number slightly, but that's why 3-inch, way better than 2-inch. 4-inch, way better than both of them. So big filter is very important. That's 24 by 24. Also, let me just show you this real quick. This is the distribution of the house. You should be able to calculate for this. But anyway, here you're gonna see the rooms in the house start to pick up. We've got crawl space, we've got master bed, we've got studio, and then one other. Why is it not? Come on now. So 72.7 is 73 degrees, 53% relative humidity because you guys are in here. 54% relative humidity, 62 degrees, 71.4 degrees, 53%. And then the crawl space, I think, is going to come up in a second here. And you'll see. But is anybody unhappy with that spread of temperatures? That's first floor, that's crawl space, first floor, second floor. And the studio even, which is on a separate HVAC system, right? It's like, this is fine. You don't need room by room returns. And that's part of what I wanted to experiment with is like, I heard that you have to add flex duct at the end of all these hard ducts for 3 feet just to cut down the noise. Right? It's pretty quiet. I like that it makes at least that much noise so I can hear when I'm in bed if it turns off during the night, which it does when it kicks into recirc or defrost mode. Here's our Haven, 100 out of 100 air quality, until you guys came in probably. Dehumidifier set to 50. And then here is Radon, less than 1 all the time. We got PM1 in the green, PM2.5. This is from the air things over there. I really like that. This is CO2. God damn it. We're at 2135 right now. I got my ERV on boost. It's okay. We're going to leave the room in a few minutes. We're all dying. VOCs, again, you guys stink. Temperature, you can see here. This was me prepping for you guys right here, like knowing that there's going to be a bunch of people in here. And then humidity, flat line. Okay, now, one of the things that you'll hear as far as the dehumidifier goes, and I know that this is dragging on a little bit, I'm gonna set you guys free, I swear, in just a second, is that you are evaporating the wetness on the coil if you keep your fan on mode and never let it turn off. Does anybody see a humidity problem of re-evaporating our coil? It's been running for 5.5 years nonstop. That's what it looks like for 5 years, it's flat. That's why you have supplemental dehumidification. Everyone should have this. I have a client who has 70% humidity inside in South Dakota last week, right? It happens in California, it happens everywhere. Okay, so real quick, we're just gonna finish this up. Boom, there's the makeup air system. Real quick, Trey, we're at positive 1.6. Watch this real quick, okay? I'm gonna turn this fan on all the way to high. Let us know what happens over there, Trey. -7, -12, -22, -35, -44, passing 50, passing 56, passing 60, passing 65. Oh, going back down. So right now, the makeup air system has said, okay, got it, memo taken, and it's monitoring the amp draw, and now it's gonna run this thing all the way up so that it reaches parity on the amp curve that it has been programmed to, and it'll hit basically 0 on that. That's what it sounds like on high, by the way.
And that's why there's detail under the cabinets. Is a little bit negative.
Yes. So makeup air down here, if you're using toe kick, 1 foot per 100 CFM, and that shows it down to 300 feet per minute. So it's all the way down here. That's a silencer right there. So we got exterior mounted fan, which I love. You can see it outside the wall here if you take a walk outside. And then the silencer, this thing costs, anybody know what this costs? 150 bucks. Like, thank you. And then this thing is a little bit pricey. This is just a bunch of sheet metal. There's no fan in there. That's the first thing, is get the fan out of your face. You gotta get it outside. That's the highest that fan goes. Most people don't use kitchen exhaust because it's so freaking loud. You don't have to do it that way.
So
we built that ourselves. Like, anybody can do this.
But the other problem is, I'll be cooking just something small, just a little, and so I only turn them on a quarter.
And then we'll come back in the morning. Yeah.
You forget.
Yeah. So happy to take questions now. You guys go 20 minutes, explore. Again, studio, crawl space, tiny house. I'm going to be in here. Grace is going to be in there. This is how you use this. You can go and test if you are worried that I'm lying to you. Take this thing, you hold it up to the exhaust grill, you press this button, and it'll spin and say, oh, I'm reading a negative. You press the button and it activates the fan and it induces a similar flow, and then it tells you what that flow is, okay? So feel free, take this, take infrared cameras, just bring all this stuff back to me.
Before everyone walks away, we just want to do our end of the thing meetings while we sketch out this. Next month, we'll be back at South Face. We've got Andy Pace is flying in. He runs the Green Design Center. It's a green building supply company. He's got some really good information on healthy buildings. So make sure you RSVP for that. And then go ahead and save the date for December. I'm not going to tell you who it is, but if you care at all about those, you will want to.
Nice. Thank you guys so much. Awesome. Thank you again, Fantech, and thank you to InsoFast.